Hello, my name's Nick Dale. I'm a Superintendent in West Midlands Police. I'm going to talk to you about the National Data Analytics Solution, or NDAS. So you'll have a short introduction from me. I'll then hand over to Ian O'Gara from Accenture, who will talk about some of the detail behind the data science that sits behind the development of advanced data analytics. And then it'll be back to me for a more detailed update as to the state of the use cases we've developed. So the National Data Analytics Solution is currently a partnership between 8 forces: West Midlands Police, West Yorkshire, West Mercia, Warwickshire, Staffordshire, Merseyside, the Met and GMP, plus the NCA. And the idea is to share data, to connect with the forces and with the data to identify a problem statement and to identify how we can use the data to answer that problem, to predict a policing and partnership response, and then to learn from that so that we can continue to reiterate the data analytics. The idea is that not that NDAS will decide what interventions are put in place, but it will be to develop insights for local forces to put interventions in place. The journey we've been on started back in 2016-17, when a decision was made that whilst West Midlands Police, like other forces, were developing the capability to apply data analytics to policing problems, that we would try to develop a capability for all 43 forces across England and Wales, so that we weren't answering the same or similar question 43 different times. And we were able to provide a more efficient and effective way of answering those questions. So we developed this through the foundation phase, where we developed proof of concept around 3 use cases: most serious violence, or MSV, workforce wellbeing, and modern slavery. We're now well into the acceleration phase, where we're developing those use cases for operationalisation, and we've also developed, or we're in the process of developing, new use cases. So you can see the 5 use cases that are in different states of development. The modern slavery and MSV use case, as I said, are the most well developed. We've got organised exploitation and firearms, which are in development, and workforce wellbeing, which has been paused. And the different use cases have different features. So modern slavery is an exploratory use case. It's about identifying known and unknown cases of modern slavery, about visualising the networks to a force so that the force can understand the threat and put resources and partnership resources towards that threat accordingly. In MSV, it's about identifying individuals who are most likely to go on to commit most serious violence, to classify and prioritise those individuals. Organised exploitation and firearms are use cases which are currently in development, which identify networks around those threat types to help the force understand and deal with that threat. Workforce wellbeing is a use case which is currently paused for various different reasons, but it essentially sought to identify individuals who are most likely to go off sick and the reasons for that. The point here is to talk about is to highlight the different data science techniques which are common across all of those different use cases, and the idea of NDAS is to industrialise this so that we're not constantly reinventing data science techniques. We can reuse what we've already used. So for example, the data visualization that's gone into it, and you'll see some of the some screenshots from the interactive dashboard later. Some of those the data visualization techniques are applicable across all use cases. NLP, or natural language processing, is similar. So the pre-processing of the words that are found in the long text in, for example, intelligence logs, is applicable across all use cases. The similarity scoring, so for example, identifying what is a knife in an intelligence log and potentially other words for knife, so that we can identify people who are involved in knife crime. again, that's usable across other use cases. So for organised exploitation, we can use a similar technique to identify common words which are an indication that somebody's involved in county lines activity, for example. So that's the idea of NDAS. The idea is to develop the data analytical techniques, to industrialise it so that we can reuse those techniques and apply them to strategic problems which are faced by the 43 forces. I'm going to hand over to Ian O'Gara now from Accenture, who's going to talk about some of the technical aspects of developing that these advanced data analytical techniques.
Thank you, Nick. My name's Ian O'Gara, and I'm the Public Sector Analytics Lead for Accenture in the UK. I spend a lot of my time working with UK law enforcement and government departments to help to improve how they use data, and I've been leading on the NDAS engagement for Accenture since 2016. I just want to spend a little bit of time, a few minutes, just talking through some of the more technical aspects in relation to the NDAS capability. If we look at the next slide, this is obviously looking like a very complex slide, but it's quite simple. This is trying to describe how we view the cloud-based architecture. Now, when we first conceived of the NDAS capability back in 2016, 2017, this was very much prior to many of the forces looking at cloud and looking at how they were going to make use of cloud-based technologies from whichever supplier. And much of our work during that foundation phase in 2018, 2019 was really focused around proving the viability of being able to take data from policing source systems into the cloud in a secure and manageable format. In the last year, we've looked to move beyond that and take the platform to a more native suite of applications. So whereas previously we were looking at what was the easiest and quickest platform to stand up, we've now been looking at what is the most enduring solution and the most cost-effective and efficient service to provide for UK public sector and UK law enforcement. So we've taken the process that we are looking at developing a suite of cloud native around AWS native services based on the cloud, with the click visualization that we've utilized during the foundation phase. And this platform really has been developed with security and interoperability in mind, and we've aligned closely with the NLEDS, the National Law Enforcement Data Program capability, to ensure that what we're doing around any cloud application works effectively with the data that they are storing. I think the effort associated with the design, configuration and maintenance of this platform should not be underestimated. I think that's one of the key learnings that we've got from this kind of work, is that wherever you are on that journey to the cloud, each organization within government and law enforcement really should be looking to define and clarify their own strategy for cloud-based storage of data where appropriate. But they really should be mindful of how that overarching government strategy for cloud works to ensure there is this interoperability, there is this focus on efficiency and process, so that there is a kind of level of reuse within the platforms, within the data. And whilst we've developed this obviously within AWS, there are a number of providers out there to be able to undertake this activity. But it can't be overstated that the alignment to the need, the use cases that you're looking to develop, the strategy and the interoperability should be key for whichever group or department you're looking at. Now, one of the key aspects that we developed this year really is around this logical data model. So one of the key issues hampering interoperability, the reuse of activities within law enforcement and broadly within government, is this proliferation of different source systems that are often off the shelf or aren't built with the level of reuse or connectivity in mind. And really, to manage this process, what we've been looking to do is to ensure, as we develop this more industrialized process, is to create this logical data model to ensure that we can actually manage data from multiple source systems, and to a degree build in a level of future proofing if it is indeed viable. Now, within the POC environment, within that foundation phase that Nick referenced to earlier, we were able just to take data straight from the source systems, land it onto a staging area, and then start to run models. And within a POC mindset, what you're trying to do is to see if there's any value there. So you're not looking at kind of creating reusable, enduring process that you can then create and deploy in an industrialized scale. But that is actually what we've been trying to do now as we move to this more enduring capability, is to build out that pipeline, that capability, so that it can take data from that source system through the staging area into more of a raw format, where you keep this raw version for reference and backup, and then to create this force layer where you are looking at kind of creating this type of data lake where all types of data are maintained and optimized and cleansed, and then taking it and then landing it on this harmonized layer where you have a series of processes all the way through up to that harmonized layer, so you then get a consistent format against the POL model. And what that allows you to do is that no matter what source system you're using within that landing area, or from kind of each of the forces, it should take you up to a consistent harmonized layer that allows you then to create these consistent machine learning models, which are then obviously highlighted a reference with the learning zone feature, learning zone image there. And the essence of this, and this just harks back to kind of the idea around NDAS, it's to create this consistent, repeatable process so that you simplify the proliferation of source systems of data that's coming from multiple areas into this centralized model, into this centralized area where you can then start to create consistent viewpoints around data and consistent views around common issues, so that you're solving things once rather than 43 different times in different ways. And just a little bit more on some of the benefits that and the value of what we've been developing over the last year as we've looked to industrialize this. We talked a little bit around that data model, but the essence of NDAS is to create that interoperability and those reusable assets. Within the data science, we've been looking to see what we can do to create capability and processes that can be used against multiple use cases. So where you see here the NLP pre-processing, the search, the network analytics, what we've been doing is to create approaches that are useful and can be lifted and shifted onto different use cases. So the aspects that we created maybe for the modern slavery use case, which Nick will talk about a little bit later, can now be used for other use cases around firearms or organized exploitation. The visualization aspects that we created for modern slavery, again, the network extensions within Click that we created as a bespoke feature, can be utilized for serious violence or for other types of use cases. So it really is that reusability, really is that consistent interoperability that we really are trying to get. And whilst we are looking to develop things within the NDAS program, if there are other things that we find within other forces that are of use to, that we think that are of use to either the NDAS program or to other forces, we would look to them almost act as the broker. So bringing learnings from other forces out to others, because we are aware that obviously there's some great activities being undertaken in certain in forces that maybe haven't been shared more widely, and it's kind of acting as that sort of central point of brokering that we look to bring as well. And again, back to the cloud platform, it's about future proofing. It's about creating kind of sort of the learnings around sort of secure, industrialized, scalable solutions that are to a degree future proofed. And within that future proofing, from a very early stage, we've been working with NLEDs because we recognize that the ultimate data store for policing data will be NLEDs. So how the two cloud platforms can work together has been critical and has resulted in a very close alignment between the two programs. If we look at also the logical data model, which we were talking about earlier, this really is bringing that data together in that harmonized layer so that it can be used at scale and at pace when we're bringing other forces in. Obviously, we developed it firstly with niche forces, and so hopefully, as we develop other niche forces onto the platform, that will allow for a quicker and more effective process of acquisition. Hopefully, there'll be kind of a greater level of alignment towards this kind of model as we develop that force. But that knowledge can be then used with other connect systems, capture systems as we develop it, creating replicable models as our understanding and our learning increases. One final point then on the DevOps engineering as well. We've also developed this data pipeline as a reusable asset, so that the patterns, ingestion, and transformation frameworks can be used against these multiple sources of data. And that really does allow us then to have this base platform of activity and knowledge and process and approach that can be deployed to whichever force that we bring on, or even whichever other department or other group of public sector data sets that we look to integrate with. So I will hand back now to Nick. Thank you very much for your time. I hope everyone stays safe and everyone enjoys this presentation. Thank you.
Thank you very much, Ian. What I'm going to do now is take you through some of the results from the use cases and then talk about some of the challenges that we face, summarise some of the challenges that we faced. So first of all, the modern slavery use case. This was an explanatory model to use a network-based approach to connect people and events for known modern slavery cases to help us then use that network information as a foundation to identify previously unidentified modern slavery patterns and trends. We used crimes and intelligence for this use case. We have an ambition to ingest other data sources in, and this is one of the other points about NDAS, is that it's important to keep reiterating these models to make them as efficient and as effective as possible. So the use case essentially matches nominals across these different source systems. It uses natural language processing to identify modern slavery events that are untagged, and the visualization layer is an interactive dashboard which enables the user to identify modern slavery across the force and to be able to then target different networks within that understanding to fully understand the threat, and then to be able to target and disrupt and dismantle the networks that lead to that threat. So some high-level updates then. All of the individuals identified through this use case were connected on average to 54 other individuals within our data. This is West Midlands Police data. Using natural language processing, we were able to identify 15,000 intelligence logs which were linked to modern slavery but had not been tagged as such, and 17,000 individuals who were linked to those intelligence logs. So that gives the ability to understand or to identify individuals who were previously unknown as linked to modern slavery. And you'll see the dashboard in a bit, but we would estimate that saves thousands of hours of analyst time. So it allows the analyst to focus on analysing the networks rather than manually identifying and creating those networks. So you'll see now some slides which are screenshots from the dashboard, which is an interactive dashboard going from high-level trends to a summary of what the natural language processing is saying is the current most likely trend. So natural language processing will, for example, it will identify keywords such as prostitute and forced, and then it will identify that is a current trend. So because of this format, I'm not going to take you in a huge amount of detail through this dashboard. We can also show, as you can see, a geographical view of modern slavery across a force area. And we come to my favourite view, which is what we affectionately call the Death Star, which is essentially what you can see there are each dot is an individual, and where they're linked to they're linked by events to other people. So you can quickly see there the value of this. So you can see this, the system produces this within a matter of seconds, and a user can highlight or isolate each of those networks, which will be a number of individuals, both offenders and victims, and you can highlight it and expand it to show other links, other non-modern slavery links, so to identify and understand the polycriminality around those CGs, and then really understand it to identify identify opportunities to disrupt and dismantle those networks. So most serious violence next, and this is where, if you saw my trailer, this is where I advertised that we would talk about a use case that goes wrong, and as I said earlier on, what we're trying to do here is connect with forces to understand the data, to identify how to solve the problems that forces face, to predict what police activity is likely to solve that problem, or to help predict where the activity should take place, and then to learn from that. And so we're going through this process with MSV at the moment, where we had a model which we believed identified and prioritised individuals as most likely to commit a most serious violence offence using a gun or a knife. What we found is, and we thought that we had a precision rate there of somewhere between 54 and 74%, so we could identify a cohort of about 150 to 150 people who we could be confident to a reasonable degree that they would go on to commit their first MSV offence using a gun or a knife within the next 2 years. So as you can imagine, this we felt was a really powerful insight. However, on reviewing and re-reviewing the code that went into that, we identified an error, a slight error, which was literally one number written wrong within tens of thousands of lines of code, which meant that precision rate could not be relied on. So therefore, we're now in the process of reiterating that, identifying a number of different options, which change the variables in the use case. So those variables of first case, gun or knife, weapon, and those sorts of things. And what we have there is what we call option 5. Taking out all of those variables, so sticking only with MSV, we believe that we can, with a reasonable degree of precision, so between 30 and 50% precision, identify someone who is going to go on to commit an MSV offence. The problem with that is that we don't necessarily have a point of intervention, because these are all people across all the data, not necessarily first-time offences, not necessarily offences using a gun or a knife. So what we're working on now is to identify how that can support current decision making. So, for example, in certainly in Met and in West Midlands Police, there are processes to identify people who are most likely to go and commit knife crime, so that interventions can be put in place. So we're working to understand how we can potentially use the data science to augment those decision making processes. Obviously the data science that goes behind it is flawed, but what you can see now are some of the ways that the insights can be presented through the dashboard. And again, I'm not going to dwell on this too much, but what you can see here is an ability to understand how that individual's risk rose over time, because there's a difference between the data science and the individual police officers or professionals' decision making. And one of the main points about data analytics is it doesn't take away the responsibility of an individual, or the professional judgment of an individual to make that decision. So we'll be able to show how the risk rose over time, and as you can see there's a spike in offending in that orange line going up, and you think, well, what happened during the life of that individual to increase the risk? So it's what in offender management terms is a contextual understanding of that individual. So we've got the actuarial, we've got the numbers and the risk that goes into it, but before an intervention is put in place, you know, the decision maker is going to have to understand the context. But what this will help the user and the decision maker to do is understand when the risk rose, so they can do a deep dive into the life of that individual, to understand why that their risk is elevated, and then understand what interventions can be put in place as a result. So on to new use cases next, and I will talk briefly about organised exploitation and then firearms. So the organised exploitation use case is an attempt to use crime, intelligence, missing person and OCG data to identify nominals involved in organised exploitation, to link those nominals to events, to use natural language processing to identify cases of organised exploitation. So, for example, linking the drugs lines names to linking common language, things like deets and squares, to linking more standard language around organised exploitation to understand who's involved in organised exploitation, to then understand what the networks are, what the networks look like, and then to classify the individuals in those networks. And at the moment we're using the terms management and workers, so that we can understand who is potentially being exploited and who are potentially the exploiters in those networks. In terms of firearms, what we are doing is network analysis and natural language processing on crimes, custody, intelligence and OCG data sets, to look at linked locations, linked events and linked nominals, to look at the types of firearms used and historic time trend analysis, so that we can seek to identify the networks of people around developing trends in firearms. We've also done an exploratory data analysis around the NDAS extracts, which we can't currently ingest into the NDAS platform, but once we can, it will significantly enhance our dashboard view. So hopefully that's given a flavour of what NDAS is about, what we are trying to develop. What I wanted to do just to finish is to talk about some of the key challenges that we are facing. around data sharing, ethics, and just a quick summary of some of the technical challenges. So first of all, around data sharing, one thing that has been really challenging is to negotiate with each individual force to share, for them to share the data to be able to ingest it on the platform. We have a security working group to work with those forces to iron out any of the difficulties they have, but we continue to face a number of different challenges in terms of being able to simply get hold of data from other forces. And we're working with obviously the other forces themselves, but also the Home Office to hopefully identify a more efficient way of doing this. And like I say, the security working group, which consists of the sort of InfoSec and data protection people from each forces, is making progress in smoothing these things out and developing a common standard of documentation for use across other forces. In terms of data ethics, this is a really challenging area. This is there is no, it's a national project. There is no national scrutiny panel for the development of and delivery of advanced data analytics. This is it is important that there is independent scrutiny. There are some models here which, as you can see, people might term predictive and will have a greater impact on the public than others, and it's quite right that these are scrutinised ethically. I mean, at the moment we are going through the West Midlands Police Ethics Committee, which is there not to say yes or no. They can't stop us doing things, but they're there to advise the chiefs and the PCC's offices on what should and can be implemented, and obviously we do have to listen to that advice. And finally, the technical challenges in doing what Ian described in terms of ingesting the data, to transforming it to that harmonised layer to apply advanced data analytics. We found technical challenges in West Midlands Police as the lead force in doing this. As each police force develops its own data model, we need to change what we do in order to ingest the data onto the platform. So those technical challenges shouldn't be underestimated, but what I can say is that as different forces go onto common platforms such as Niche and Athena, we anticipate that the ability to onboard new forces onto the project should improve. So that, I think, is it from the NDAS presentation. If you want to get in touch with me to ask any questions, or if you want to know more, then you should see my email address popping up. And other than that, enjoy the rest of the virtual conference, and thank you very much for listening.